There was no keynote, no countdown, no demo reel, no executive pacing a dark stage, just a repository, a specification document, and a version number, Agent Plugins 1.0.0, published jointly by Versal, Google, Amazon Web Services, Microsoft, and OpenAI, 5 companies that compete for the same developers, the same enterprise budgets, and increasingly the same customers. Standards work almost never makes headlines. It should here. Because what these 5 agreed on isn't a product, it's a file format, a manifest called plugin.json, and it may shape how AI agents actually get used more than any single frontier model launch this year. To understand why, start with the problem developers have been quietly absorbing for 2 years. Every agent surface built its own extension format. IDE assistants have rules files and extension APIs. Command line agents have their own configuration conventions. Cloud agents have theirs. Chat platforms have another. So a team that builds one useful thing, a deployment tool, an internal database connector, a compliance checker, packages it 5 separate times. 5 sets of documentation, 5 release pipelines, 5 places where it breaks. That's an integration tax. It's paid in engineering hours, and it quietly caps how much any single tool can spread. According to the published specification, Agent Plugins is deliberately narrow. It defines packaging, not intelligence. The manifest declares identity and a semantic version. It declares capabilities, the tools, commands, and prompt assets a plugin contributes. It declares permission scopes, what the plugin is asking to touch. It declares entry points, so a host runtime knows how to load it. And it declares dependency and distribution metadata, so it can be resolved, installed, and updated like software. What it does not define is model behavior, reasoning, or a new network transport. It is a contract about shape, not substance. That restraint is the point. Model launches dominate attention. They shouldn't dominate analysis. Frontier models are substitutable and depreciate fast. Something announced as state-of-the-art in the spring is a cost optimization footnote by winter. Interfaces behave differently. Interfaces compound. Once a manifest format is widely adopted, every tool written against it keeps working as the models underneath it get swapped out. The plugin outlives the model. The ecosystem outlives the vendor. Which is why the more consequential question in agentic computing was never whose model is smartest. It was, who controls the extension point and can anyone build on it without permission? There are 2 clear precedents. The first is NPM. Before 2010, sharing JavaScript meant copied files, manual script tags, and no reliable way to state that your code depended on someone else's code. NPM, created by Isaac Schluter, didn't solve that with clever technology. It solved it with agreement, a package.json file that everyone filled out the same way. The registry grew into millions of packages. Whole categories of tooling became possible only because dependency resolution was a solved, boring problem. The lesson is unglamorous and repeatable. The value wasn't the code. It was the shared shape of a package. The second precedent is closer. In 2016, Microsoft published the Language Server Protocol alongside Visual Studio Code. The framing was explicit. Editors times languages is a multiplication problem. Every editor needed bespoke support for every language. M editors, N languages, M times N integrations. LSP turned multiplication into addition. Write one language server. It works in any conforming editor. Within a few years, editors that were direct competitors of VS Code, NeoVim, Emacs, Sublime, later Z, all spoke it. Agent Plugins is attempting the same arithmetic. Agent Surfaces times tools becomes Agent Surfaces plus tools. Build once, run across IDEs, CLIs, and cloud agents. The obvious question, what about the Model Context Protocol? MCP was released by Anthropic in November 2024 and adopted through 2025 by OpenAI, Google, and Microsoft. An unusually fast convergence, later reinforced by moves toward neutral, foundation-based stewardship. But MCP and agent plugins answer different questions. MCP is the wire, how an agent talks to a tool at runtime. Agent plugins is the wrapper, how that capability is named, versioned, permission-scoped, distributed, and installed. HTTP versus a package. Worth noting who is not on the 1.0.0 announcement list, Anthropic, MCP's originator. That absence is not evidence of conflict. It is something to watch. Now, the honest counterweight. Recent history includes a cautionary case. OpenAI launched ChatGPT plugins in March 2023 to enormous developer enthusiasm, then deprecated them the following year in favor of a different model. Vendor-owned extension points die on vendor timelines. The likelier failure mode here isn't rejection, it's extension. Each platform ships plugin.json support, then adds proprietary fields its own runtime privileges. The baseline becomes a lowest common denominator, and works everywhere quietly means works fully in exactly one place. That pattern has a long record: browser-era HTML, SQL dialects, Kubernetes distributions. Superset is how you fragment a standard while claiming to support it. So the tests are specific, and they're observable within months. Does governance move to a neutral body with defined membership, or does the spec live in one company's repository? Is there a conformance test suite, the mechanism that made LSP claims verifiable? Is there one registry, or 5 competing catalogs with vendor-specific metadata? Do open-source runtimes and independent editors adopt it without special casing? And critically, is version 1.1 negotiated jointly, or does someone ship a fork? There's also a security dimension that deserves separate scrutiny. If agents can discover and install plugins semi-autonomously, then those declared permission scopes are the entire trust boundary, and permission manifests have historically been treated as paperwork rather than enforcement. Agent Plugins 1.0.0 is not a breakthrough. It's an agreement, and a fragile one, because it depends on 5 competitors continuing to find shared plumbing more valuable than proprietary lock-in. If it holds, it becomes invisible infrastructure, the way package.json and LSP became invisible. Boring, assumed, load-bearing. If it fragments, we get 5 dialects and a compatibility matrix, and the integration tax simply moves. The specification itself is public and versioned, which means, for once, this isn't a claim requiring trust. It's a document you can read, and a set of promises you can check against what these companies actually ship next.